Okay, welcome. Let's get started with chapter 1. Let's just jump right into it. We're going to start with lesson 1. We're going to estimate products of fractions. Before we go any further, I just want to remind you this chapter, the essential question is, what does it mean to actually multiply and divide fractions? Okay, just keep that in mind. We have two goals for this lesson. We're going to estimate using compatible numbers, and we're going to estimate using benchmark fractions, 0, half, and 1. We're going to round one of these threes, and I'll explain that later, what I mean by that. A reminder, what are compatible numbers? They're numbers that are easy to multiply and or divide, and if you notice a side note, they also make it easier to add or subtract. Okay, it's kind of like rounding, but not necessarily, depends on the situation. And I'll explain with examples when we get to it. All right, so for goal number 1, for this lesson, compatible numbers will help you with division. All right, so here we go. We're doing the got it's on page 258. And we're going to start with A, B, and C. That takes care of goal number 1. So here we go. Got it. We have 1/5 times 16. All right, before we do anything else, I should explain what's going on here. Okay, visually, this is 1/5. You look at the denominator always. We want something with 5 parts. 1, 2, 3, 4, 5. So 1/5 times 6, what does that mean? Okay. 1/5 of 16. If it helps, you can also look at it like this: 16 groups of 1/5. How many fifths do we have? Right? In 16. Yeah? If we're making groups of 1/5, how many groups of those can we make out of if we had 16? Okay, so we have 16, right? We want 16 groups this. You could say it the other way around. 1/5, 16 times, right? Either way, it's just another way to look at it. Okay, so remember this is 1/5. We want 16 of those, or 16 groups of 1/5. What's going on? So this is where the compatible number comes in. Somehow I want sets of 5. Okay, I want sets of 5. And since we're just estimating, here's the deal. I have 16. All right, how many groups of 1/5 can I make out of 16? Now, if I'm going to break this up into fives, groups of 5, right? What number would be easier to divide into groups of 5? 16? Or what about 15? Those are compatible numbers. 5 and 15 are easy to divide. 15 divided by 5, you should be able to see. Again, here's the deal. I want sets of 5. 16, no, it doesn't divide evenly. But 15 does. Remember, we're just estimating, so it's not going to be a perfect answer. So with that in mind, see what's going on. I'm going to change, and you already see what the answer is going to be, but here we go. Let me show you all the work. I changed the whole number to a fraction by adding a 1 under it. So it's 1 times 15 over 5 times 1, which is just 15 over 5 over row 3. I wrote the answer. It's 3. Okay. I hope this makes sense. I'm going to do another one. I'm going to do letter B, and then we'll do letter C, and we'll go from there. Letter B. There you go. 5, 6 times 13. Okay, one other thing I want to mention. I didn't say this with the other example, but I'm going to say it now. 13 times 5/6. This is less than 1, right? So I predict my answer is going to be less than 13. Okay? 13 times 1 would be 13. But this is not 1, it's less than 1, so my answer is going to be less than that. Okay? less than 13. So I have 5/6. I'm going to do it another way without groups of. I'm going to keep the order as is. And hopefully you'll see why in just a moment. 5/6. Visually, what does it look like? I'm making sets of 6. I always look at the denominator. When I work with fractions, I always look at the denominator first. Always. Okay? I'm making groups of 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. So here's 5/6 if you can see it. Now, the question's asking, if I have 5/6 and I do this 13 times, if you can imagine me drawing this 15 more times, 5/6, 5/6, 5/6, 5/6, 5/6, 5/6, what would that come up to? How many of these sixths would I have? How many 5/6 would I have? And if you notice, I keep saying it funny because it's a fraction. But 5/6, 13 times, if you think of it that way. Now, I'm thinking of compatibility. I have to make groups of 6 out of 13, again. But since we're just estimating, I have to think of a compatible number. So there's my 13. Here's on the side. I'm making groups of 13, sorry, groups of 6, and I have 13 to work with, right? I can do that, and it'll give me this, and it'll give me some decimal number or some other fraction. But a number that works better for 6 is 12. 2. That means I have 2 5 times. 2, 4, 6, 8, 10. Don't forget the other one, right? That's 12, yes? So instead of 13, if we made it 12, 12 and 6 are more compatible. You can see that you have 2, 4, 6, 8, 10. The answer is going to be 10. And the original prediction I made was the answer is going to be less than 13 because I have less than 1. But let's do the work. All right. 5/6 times 13. But I'm going to change it to 12 because 12 is more compatible with 6 in terms of division. Put a 1 under to make it a fraction. I multiply the numerators together, I get 60. Multiply the denominators together, I get 6. And the answer again is 10. Hopefully you should be able to see why it's 10. Alright, let us see again. Again, we just did it first time. Tired. Long day, people, long day. 3/4 times 23. Again, let me show you visually what's going on. I want 3/4 23 times. Yes? Another way to think about it, you're making sets of 4, right? You have 23 holes, and you're going to break all these up into fourths, but then for all the fourths, you're going to collect three of them at a time. Groups of 3, groups of 3, groups of 3 out of those. I'll show you later what I mean by that, but for now, the big picture. We're making sets of 4. How do I know it's 4? Because the denominator is 4. 1, 2, 3, 4. And the fraction we want is 3/4. How do I know that? Because it's right there in front of me. 3/4 23 times. Or 23 groups of 3/4, right? 3/4 23 times. But let's shade it in. 3/4 is 3 out of 4. 1, 2, 3. I have here the number 23. And since we're estimating, I want to be able to do this in my head quickly, right? Because this is not going to work so well. I'm going to have some decimal number. 23 is not compatible with 4. However, you might be able to see this. 24 does work. Look at that. Easy division. That means each one of these pieces is 6. 6, 6, 6, 6. But I only want 3 of them. So the answer in this case is 18. And I'll do the math so you can see where I'm going with this, okay? But I want to show you how this works, okay? So 3/4 times 24, change it to a fraction, yes? So 23 becomes 24. I told you, and I showed you why. Eventually, guys, you'll be able to see in your head, hey, I'm dividing something by 4, and here's the numerator I'm working with. That doesn't work. You can just do it in your head. Oh, it's going to be 24. You'll do this right away. You won't have to go through all this business here on the side. But you know what? It's okay if you have to. If you want to do the drawing first, get the answer that way, and then confirm it with the math without the drawing, that's fine too. The more you do this, the faster you get at it, so there's no shame. 3 times 24 is 72. Again, we're multiplying numerators, multiplying denominators. Okay, so we're going to divide 72. 72 is the dividend. This is the divisor. It's the quotient. All right, we're making groups of 4. We're going to go place value by place value. All right, I'm making groups of 4. I look at the 7. I can make one group of 4 out of the 7. Yes? 7 minus 4 is 3. I bring down the 2. 4 times 8 is 32. And again, it's just times tables. I'm just looking at times tables. I know my times tables. This is why I'm going kind of fast. So again, the answer is 18, and you already saw that. It is 18. Okay? And right here again, just so you can see. Okay, now we're going to work with goal number 2, which is working with the benchmark fractions. I think I said that funny. Benchmark fractions. Forgot to pronounce the K. All right, 3 fractions you need to know. 0 really not a fraction, but you know 0 when you see it. You have nothing. Half, you have 2 equal parts. Yes? And 1 is when you have everything. Yes? So you're going to use the idea of 0, 1, and half. Okay? You'll round up or down depending on the fraction. Now there's 3 things to look at to realize. If the numerator, which is the top number, is almost as large as the denominator, you round up to 1. Some examples. 7/8. Well, the numerator is just 1 away from the denominator. Pretty close. You can kind of see it in your head. This is almost the whole thing. So that's pretty close to 1. Again, we're estimating. So you're kind of, it's not going to be an exact answer, but it's pretty close. Same thing with 4/5. 4 is only 1 away from the 5. So that, hopefully you can see, it's pretty close to 1 as well. All right, other conditions you have to think about. When the numerator is much smaller than the denominator, you round down to 0. Okay? There it is, what I'm looking at right here. So for example, 1/10. The denominator is 10, and you have 1 out of 10. 1 is really far away from 10. So you're pretty much close to nothing. So you say it's 0. You just change it to 0 instead. Again, we're just estimating. It's not the exact thing. 3/9. Okay. Again, denominator is 9. The numerator is much smaller than the denominator. You can say that's the same as 0, or pretty close to 0. The other situation is when the numerator is close to half of the denominator. You change it to a half. Okay. Some quick fractions, some quick examples. We have 4/9. I look at the denominator. Half of 9 is 4.5. I wrote that here. 4 is pretty close to 4.5. So I'd say I'm going to change it to a half. Okay. Now 4/7. Half of 7 is 3.5. 4 is pretty close to that too. It goes over, but that's okay. We're estimating. It might go over, it might go under. That's okay. Here it went under, here it went over, and that's okay. Still half. Okay. Now we're going to work on the got it's on page 159, D, E, and F. And I hope this works. Let's see if this helps you guys figure this out. All right. 5/8 times 9/10. All right. Here's the deal. I'm going to write down what I drew earlier. 0, half, and 1. Okay. 9/10. 5/8. All right, 5/8. I look at the, again, remember I said earlier, look at the denominator first. Denominator is 8. Half of 8 would be 4. 5/8 is pretty close to half, right? It goes a little bit over. So 5/8 would be right here. Now, look at this, 9/10. 9/10. Denominator is 10. Half of that would be 4.5. But look at this, you have 9. We're one away from the 10. So I'm going to say that this is close to 1. Okay. So the 5/8 is close to half. So I'm going to change the 5/8 to half. And the 9/10, I'm going to change that to 1. going to multiply to get that together. Okay, all right. 1/2 times 1, or one group of half. Well, 1/2 is just 1/2. If I only have one group of it, the answer is just 1/2. Okay? Let me do the math just a little bit more so you can see 1/2 times 1, 1. Again, you put a 1 under the whole number, change it to a fraction, multiply it out. 1 times 1 is 1, 2 times 1 is 2. There you go, half. I'm just showing you with the math. I showed you visually why this works, why you estimated it, why you changed it to half, or why you changed it to 1. And then you see here the actual math. All right, so that was letter E, or sorry, D. Letter E. 5/6 times 9/10. Okay, I think some of you might already see where this is going. All right, same idea. I'm going to draw this. If you can do this neatly, that would be even better. Nine-tenths. I've done it before, so I'm going to do this here again. All right. 5/6. Oh no. The denominator is 6. Half of 6 is 3. The numerator is 5. There's actually 1 away. It's more than half, and it's pretty close to the denominator. So 5/6, I'm going to put it somewhere here. You know, it's going to happen. This is pretty close to 1. This is pretty close to 1. What's 1 times 1? 1. Okay. Hope that makes sense. One more to go. F. 5/6 of. I'm writing the word of because I forgot to mention something. So it's automatic for me, but maybe you still don't understand. When you see the word of, it means you're going to multiply. All right, so I'm going to rewrite the problem again, just so now you know where I came with that. All right, same thing on the side. 0, half, and 1. Okay, the half should be closer to half, but again, it's just visualization. All right, 5/6. 5/6. Look at this. 5/6. Half of 6 is 3. 5 is more than 3, so it's more than half. And actually, it's pretty close to 6, pretty close to the denominator. So I'm going to put 5/6 here. It's pretty close to 1. Yeah? 1/9. I'm looking at the denominator first. Half of 9 is 4.5, but the numerator is 1. That's less than half, and actually, it's only one part away from 0. So I'm going to put the 1/9 somewhere here. Okay, so 1/9 becomes 0. 5/6 becomes 1. You have 1 times 0. 1 times 0 is just 0. And that's it. Do not make it harder than that, okay? What you have to understand is the concept of 0, half, and 1. That's the first thing. Second thing is you have to know how to divide things in 2. Half of 9, okay, 9 is pretty close to 8. Half of 8 is 4, but I have one more. Half of the 1 is half, so 4.5. Or you can just do it again, if you can't do it in your head, no shame, unless I'm just doing this, right? Four and a half. Okay. You should be at the point where you can do this in your head, and if you can't, that's okay. Divide. Okay? Divide the denominator by 2 to get the halfway point. But I was going to say, understand the concept of 0, half, and 1. Understand how to divide a denominator by half, to 2 parts, and then you look at the numerator. Is it close to the halfway point, far away from the halfway point? And if it's far away from the halfway point, well, is it closer to 0 or is it closer to 1? Okay, it's just using your eyes. Again, there's no shame in doing this. You don't have to do this all in your head. I mean, eventually you will get to that point where you can do it in your head. But there's no shame in drawing this real fast. It only took, what, 5 seconds, if that? You can do it.